Hey everybody, welcome to, this is section 8.5, so it's graphing linear equations and graphing in two variables. This is stuff that you have done at some point in your math career. This is a review section really that they add on sort of to the end of this course. It's just part of what we do here. So this is technically in two parts, but both parts are pretty short. Most of what you are seeing in here should be stuff that comes back pretty quickly. So when we're talking about graphing and linear equations, we're talking about things in the Cartesian coordinate plane. So all that means is the coordinate grid that you have seen for years and years and years, right? The coordinate system has an x-axis, has a y-axis, has an origin, has 4 quadrants, and every point on the coordinate plane is determined by an ordered pair, by a location, right? This is the idea of a location, right? Remember that the first number is always the x-coordinate and the second number is always the y. This is a picture that is too big that I can't make smaller. So, you know, the x-axis runs horizontally, the y-axis runs vertically. The origin is the point in the center, and then the quadrant numbers are always the same in the same order. So we have quadrant 1 up here on the right-hand side, quadrant 2, quadrant 3 here on the bottom, quadrant 4 on the bottom right. It always is counted counterclockwise, and they're always counted in Roman numerals. That's just standard math practice, okay? So when you talk about quadrants with kids, these are the ones you can't rename them. You got to do the order they are. So take a minute, plot some points, make sure that this is something that is comfortable and you don't do backwards, because if something happens, that's what goes wrong. Remember, the first coordinate is x. We move to the positive direction to the right, negative direction to the left, just like we would on the number line. Positive up on the y-axis, negative down. Okay, so take a second, plot some points. I will take a second and do the same. I'm going to label mine with letters, just because that way you can know which point is where. So point A is negative 3, 4. So 1, 2, 3 to the left, 1, 2, 3, 4 up. Give your point, give it a label. B is 5 and 3, so 1, 2, 3, 4, 5, and then down 3. Okay, that's B. So A is a quadrant 1 point, B is a quadrant 4 point, C is 4, 0, which means 1, 2, 3, 4 over to the right and not up at all. So C is not in a quadrant, it is on the x-axis. D is not up, not to the left or right, but up 5, which makes it also not in a quadrant, but on the y-axis. Negative 2, negative 4 is to the left 2. Down 4, that would be E. Ooh, that's not a very good E. E is in quadrant 3. And 2, 5 is over to the right 2 and up 5. That's point F. That is also in, oh, A was in quadrant 2. Sorry, in quadrant 1. So here's our coordinate grid. We have plotted our points. All is well and right in the universe. So moving on from here, when we talk about linear equations in two variables, they are things that are represented as straight lines on the coordinate plane. If you graph a line, an equation, and it's ax plus by equals c, it's in this form, or it's in any other form where there's just an x and a y involved, there's no squareds, there's no cube, there's no nothing. If that happens and you don't get a straight line, something went wrong, okay? These below here are all just examples of linear equations. Sometimes you'll have just an x equals something, sometimes just a y equals something, but these are all going to make straight lines because there is no quadratic in here, there's no squared, there's no cube, there's no nothing, and we're in two variables technically, because when x equals 7, we can know y equals nothing, y equals 0. When y equals 5, x equals 0. Okay, so it's sort of an implied 0. So there's lots of ways to graph equations. The easy fallback, position 1, is always just to put your points in your equation, plot them, and move on. We can use an intercept method where we talk about where it crosses the x and y axis, and we can also use slope intercept, which I'm sure you've used before. It will all come back. So when we plot points, basically what we do is we choose three at least values to substitute into the equation for either x or y. Generally speaking, we substitute in for x to get y. It's often easier, but depends on the equation you're given. Solve for the remaining variable, you get your ordered pair, you plot them. Your 3 points should be collinear. Collinear is fancy for should be on a straight line, okay? Notice that we said 3 here. All right, here's the thing. You are gonna wanna plot 2 points, right? So if I draw my graph, I plot first point here, I plot the second point here, I draw a straight line. Look, I have a straight line. But here's the thing. If either of these points is wrong, say that one is incorrect, then your line is totally wrong. Because maybe you plotted 3 points and you discovered that it should have looked like this. So if you'd plotted your 3, you would have gotten 1, 2, and 3 and gone like, oh, wait, gosh, that's not a straight line. There's something wrong. 3 gives you a way to catch a mistake, and it's an important thing to do, okay? We're all about teaching you, but also teaching the kids you'll someday be teaching how to minimize sort of the errors that they can make. This is one of the important ones when you're graphing. So if we want to graph 2x minus 3y equals 6, here's our linear equation, we can make a chart. Often they are like a little t-chart. So you have your x coordinate and you have your y coordinate, and you choose to put in. All right, in this case, they're choosing 0 for x, 0 for y, and then just some other number for your third point, which is fine. Something that'll make it easy on you. So when I put in 0 for x, I get 2 times 0 minus 3y equals 6. That makes a 0 here, minus 3y equals 6. Divide by negative 3. Y equals negative 2. Okay, so negative 2 there. That means my point is 0, negative 2. If I put in 0 for y, I get 2x minus 3y equals 6. 2x minus 3 times 0 is just 0 equals, 6 divided by 2. X is 3. So 3 in for x, and here's my coordinate, okay? And then I'm gonna put in negative 3 for x, because, you know, or I could put a 1, or something that's gonna make it work out nicely though, so we don't have some funky thing to do. All right, give myself some room. So 2 times negative 3 minus 3y equals 6. I get negative 6 minus 3y equals 6 plus 6. So I get negative 3y equals 12, which means when I divide by negative 3, y is negative 4. Okay? And then I just need to graph these. Negative 3, negative 4. So on the next screen, there's a graph, 0, 2. All right, so my points were 0, negative 2, 3, 0, and negative 3, negative 4. Okay, so I'm going to graph them. So 0, negative 2 is over not at all, but down 2. 3, 0 is over here. 1, 2, 3. And negative 3, negative 4 is back 3, down 4. And now if I look at those points, they look collinear, right? I can draw a straight line through them. If I can actually draw a straight line, we'll see. Let's see. Yep, a little harder on this pen, right? Okay, so there's my graph. Straight lines never end like this, so they get arrows on the ends. And I'm going to write my equation on it, which was 2x minus 3y equals 6. So it's labeled. All right, so we've plotted points, right? We can also use intercepts. So the x-intercept is the place where the line crosses the x-axis. The y-intercept is the place where the line crosses the y-axis. If we go back here, the line we drew crosses the y-axis here. That's the y-intercept. It crosses the x-axis here. This is the x-intercept, okay? So to do this, we do what we just did, really. We put in 0 for x, we put in 0 for y, and we plot the points. This is a different method technically than plotting points because you're strategically trying to find the intercepts, but sometimes it's just naturally what we do, right? So I am going to change the slide. Use this method to graph 4x minus 2y equals 8. Okay, so I'm going to put a new slide in here. So I have place to write 4x minus 2y equals 8. So first, take a minute and get your intercepts and your point. I'm going to use those. All right, so when I put in 0 for x, I get 4 times 0 minus 2y equals 8. Minus 2y equals 8. Divided by negative 2, y equals negative 4. Okay. If I put in 0 for y, I get 4x minus 2 times 0 equals 8. 4x equals 8. X equals 2. All right, and I'm going to put in a 1 for x, so 4 times 1 minus 2y equals 8. 4 minus 2y equals 8. Subtract the 4. So I get negative 2y equals 4 divided by the negative 2. Y is negative 2. All right, so there are my points. 0, negative 4, 2, 0, and 1, negative 2. Here's the thing. You might have picked a different number here. That's fine. It should still all be on the same line, right? So let's plot our intercepts and our point. 0, negative 4, 0, negative 4. Oh, that's 4 down. Good heavens. Even I do things backwards when I'm trying to do too many things at once. 0, negative 4. Then I have 2 and 0, which is here. And then I have 1 and negative 2. 1 and negative 2. And here's the thing. If I had had my point over here, I would have noticed because my line wouldn't have made a line. Okay, so it's how you catch your mistakes. So we draw a straight-ish line. We label it with our equation, 4x minus 2y equals 8. Okay? All right. So that is the second way, intercepts. Another part of this is slope-intercept, but in order to do slope-intercept, we have to know what a slope is. Slope is the steepness of a line. So think about steep hills versus flat ground, right? Slope is the vertical change in y, divided by horizontal change. So how much you go up divided by how much you go over. In a lot of cases, somebody explains this to you as rise over run. But really what it is y2 minus y1, x2 minus x1. Okay? We're going to find the slope between the 2 points. What matters is not what order you do your y's in. What matters is that whatever order you choose, you do the x's and y's in the same order. Okay? It doesn't matter which point is 1 and which point is 2. What matters is you do it the same way in the numerator and the denominator. When in math, when you see a lowercase m like this one, this always indicates slope. Okay? So in this case, when we're talking, m is slope. So we're going to find some slope. All right. So find the slope through each point. We're going to do the first one, and then you guys do a couple. So I always label my points. I'm going to make this one 1 and this one 2. Just helps me to remember. So I'm going to do y2 minus y1, 5 minus 6. And then on the bottom, I'm going to do x1 minus, I just did it backwards. See my brain. Sorry, guys. y2 minus y1. No, I was right. y2 minus y1. x1, or x2, 1, minus, and remember, this is a negative 1. Okay? So, x2, I'm using x's and y's. This is why I'm having a problem. Sorry. It's an early day here in the Torpy household. Okay. I'm going to use y points first. These are the y's. Don't laugh. X. Everybody has their moments. All right. y2 is 1. minus 6, good heavens, over x2 minus x1, 5 minus negative 1. It's so much better now. Okay. So on the top, I get negative 5. On the bottom, I get 6. So what this means is that when I'm plotting a point, so say I know I have a y-intercept here. My next point is left 5 and down 6 from where I am now. Okay? All right, you do the next couple. Try not to be as backwards as I am. Get your slopes. Okay? All right. So the next one, I'm going to make this point 2 and this point 1 and try not to make a hash of it. So 2 minus 4 divided by 1 minus 6 gets me negative 2 over negative 5, which is the same thing as 2 over 5. So the slope in that case is 2 over 5. To the right 2, up 5. All right. This one, let's make that 2 and that's 1. I'm going to do 0 minus 5 over 3 minus 3. Okay, so I get 0 minus 5 and negative 5 over 0. Uh-oh, that's not cool. Dividing by 0 is undefined, so what does that mean? Undefined means this is a straight vertical line, okay, like this. The slope of a straight up and down, it's like driving up a hill. I can drive up a hill, but I can't drive up a vertical wall, can I? So this is an undefined slope. It means you have a vertical line. The last one down here, I have 0.2, 0.1. I'm going to do 4 minus 4 and negative 2 minus 3. So on this one, I'm going to get 0 over negative 5. So 0 divided by anything is just 0. If something has 0 slope, what does that mean? No hill at all. It means flat ground. Flat ground, horizontal line. Okay? So in this case, it has 0 slope, it's flat. In this case, undefined slope is vertical line. All right. Using slope-intercept means that we have to get the equation in a form that is different from what we have right here. What we have to do is we have to transform this from this form into this form. Okay? So we can solve the equation for y, because that's what we want to do here. So I have ax plus by equals c. This is technically called point slope form. Point slope form. Okay, and I want to get it into slope intercept form, which is what this is. So I need to move this guy over, right? Minus ax. So I get by equals c minus ax. And then divide by b. Y equals c minus ax over b. It's not pretty, it just is, right? All right, so when we use slope-intercept form, here's how we go. It is y equals mx plus b. M is the slope, always. So it's the number with, it's the coefficient of x. B is the y-intercept. It's the place where the line crosses the y-axis, okay? It only works to call out m and b if your equation is in this form. If it's not in that form, you have to transform it to get it there. When you graph in this method, you plot the y-intercept, and then you use the slope to make other points. All right, so let's try one. Here's my equation, 2x, 2/3 x minus y equals 3. 2/3 x minus y equals 3. All right, so now first I have to transform this into the form I want. So I'm gonna, let's see, I wanna have a positive y, so I'm gonna add y over here. So I get 2/3 x equals 3 plus y. I'm gonna subtract 3. So I get 2/3 x minus 3 equals y. So now I have this in the right form. This 2/3 is the slope, rise over run. This negative 3 is the y-intercept. The sign always belongs to the number behind it, okay? So when I make my graph, the slope is 2/3, the y-intercept is -3. So I'm going to start at the y-intercept, down 3. The slope is 2/3. That tells me rise, 1, 2, over run, 1, 2, 3. And I can just keep going, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. I can go in the opposite direction too. I could go down 2, left 3, down 2, left 3. And then I draw a vaguely straight line. I'm going to label it with the original equation. The original equation was 2/3 x minus y equals 3. Okay, that is slope-intercept form. The other part of this, and I have to make this share a different screen, so hold on a second. Let me get to the right window. All right, I'm going to share the other screen now. Hopefully that worked right. This is just inequalities. The second part of this is taking everything we just did, all the graphing, and applying it to inequalities. There's only really one change that happens here. Two. So the solution to a linear inequality is not a line, but a half a plane. It's a whole area of a graph because, excuse me, inequalities have multiple answers, right? So we need the whole section that would solve. In some cases, it's a half a plane and the line is included. In some cases, it's not. It depends on if it was greater than or equal to, less than or equal to, greater than or less than. It just depends on how the equation was set up. So here's the process. Start by just pretending there's an equal sign. Plot the points, graph the equation. Okay? If the equal sign is less than or greater than, draw a dotted line. If it's equal to, draw a solid line. The dotted line indicates that the solution, the line itself is not a part of the solution. It's not equal to. And then you have to decide which side to shade. Okay? So if basically what you do is you choose a point. Here's my line. Choose a point over here. You choose a point over here. If this one makes the inequality true and this one does not, we shade this way, or vice versa. If neither point works, you need to check your work. So let's try a couple. I'm going to put in a blank page. So I have x plus 2y is less than 4. You can graph this any way makes you happy. I get x. Oh, I need my pen. No, why isn't it? X plus 2y is less than 4. Okay, so the first thing I notice is I'm going to use a dotted line because there's no equal to here. I'm going to transform my equation into a form I like. Okay, so I'm going to move x over here. 2y is less than negative x plus 4 divided by 2. So I get y is less than negative half x, x divided by 2, plus 4 divided by 2 is 2. Okay, so my equation, I'm going to do slope-intercept. I have negative half as my slope and my y-intercept is 2. So here's my y-intercept at 2. Negative half means I go down 1 and to the right 2. Down 1 to the right 2, or up 1 and to the left 2. So here's my line. Now it's less than, not equal to, so I'm going to draw a dashed line, which is hard to do on here. And now I have to decide which side to shade. So I'm going to choose a point over here, and I'm going to choose one over here. All right, so on this side I chose 0, 0, which I do if I can possibly choose it, I do. On this side I chose 1, 2, 3, 4, 5, negative 5, and 1, 2, 3, 4, negative 4. Okay, so you're going to fill it in for the equation. So x is negative 5 plus 2 times negative 4 less than 4. Negative 5 minus 8 less than 4. Negative 13 less than 4, yes. Okay. Da, 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 da. Okay. I'm going to put in 0, 0, 0 plus 2 times 0 less than 4. 0 plus 2 is 2 less than 4. Something is wrong with my line. Am I having a day or what? Did I change this wrong? Subtracted x. Did I get all my signs right? Yep, I subtracted x. I divided by 2, negative half and 2. Oh, I know what's wrong. Boy, I'm just going to go. My line is in the wrong spot because it was a positive 2 for my y-intercept. Maybe this wasn't the day to be recording this. Holy mackerel. So, and you can see, even when we're all trying to do just perfectly, everybody's brain makes mistakes. So down half, down 1 over 2. Down 1 over 2. My line is in the wrong spot, up 1 over 2. That is much better. So 0, 0, and both of these points were on the same side of the line. Okay, so that's why something didn't work. We're going to check that one off. Let's pick something over here. So let's see, 4. Let's pick 4, 4. Let's see if that works. So if x is 4, oops, that's a plus. 4 plus 2 times 4 is less than 4. Definitely not. This is 4 plus 8. It's 12. 12 is definitely not less than 4. So this side doesn't work. This side does. Here is where we shade. And when you shade, you just color, basically. All right. So let's do the next one. I'll try not to make a hash of it again. All right. I'm going to put a blank page behind it. We're going to graph 4x minus 12y less than or equal to 12. Okay, so 4x minus 2y less than or equal to 12. 4x minus 2y less than or equal to 12. All right, however it is you want to approach this one, I'm going to make a chart for this one. So I'm going to put in 0 and 0 and 2 maybe. Okay, when x is 0, 4x becomes 0, so negative 2y is less than or equal to 12. And I can use this as just an equal sign at the moment. Y is negative 6. When y is 0, the 2y drops away, so I get 4x less than or equal to 12. Divided by 4x is 3. And when x is 2, that's 4 times 2 minus 2y, 12, so 8. 2y equals negative 2y equals 4y equals negative 2. All right. So I have my points. I'm going to go plot them. 0, negative 6, 1, 2, 3, 4, 5, 6. Scroll down a little bit. I have 3 and 0, 1, 2, 3, and 0. And 2 and negative 2, 2, negative 2. That is going to work. So here's my line. It is solid because of the equal to. And now I have to pick a point on either side. So I'm going to pick 0, 0 over here. And on the other side, I'm going to pick 1, 2, 3, 4, 1, 2, 3. 4, negative 3. And we're going to put them in our equation. Whatever it was, it's up here. All right, so 4 times 0 minus 2 times 0 less than or equal to 12. Well, that's definitely a lot of zeros less than or equal to 12. That's true. 4 times 4 minus 2 times negative 3 less than or equal to 12. So that's 16 plus 6, definitely not less than or equal to 12. So we're going to shade this way. Okay? All right. Let's see what else is here. This is x is greater than 5. So when we think about this, we're thinking about every value of x is greater than 5. So this starts at the line x equals 5. And then we have to think about that. So x is 5 for every y, okay? So x is 5 at y equals 0, x is 5 at y equals 3, x is 5 at y equals -4, x is 5 all the way up here. It makes a vertical line. And then we have to say to ourselves, x is greater than 5. So if x is greater than 5, where are the numbers greater than 5? Well, if I have an x value that's 6, it's over here, right? It's on the right-hand side. 7, 8, 9, 10. Any x greater than 5 solves this. So there's where I shade. All right. For here, this is, oh, this should have been a dotted line, right? It's not greater than or equal to. Okay. Now, this one, solid line, right? So in this case, y is less than or equal to -2. So no matter what value of x I have, x is 0, y is -2. X is -2, y is -2. X is 2, y is -2. No matter what I choose, y is -2, which makes us makes a horizontal line. Solid in this case because of the equal sign here. And then we have to think about where are the y's that are less than or equal to -2? Well, like -3 would work, -4, -5. They're all down here. And that's it. Okay? So these are the graphs. That is the end of this section. So hopefully this is pretty straightforward. You need some practice. Go do the homework assignments and the assignments in here. And this is our last section of notes. So next week, we get ready for the final. Let me know if you have questions. Thank you.